All right, so we're going to go ahead and take a look at this challenge number 7 on slide 5. So like I said, you have calculators, so we shouldn't be worrying about the mathematics too much. We really want to think about the patterns, what we're seeing, what happens kind of, what we're noticing as we kind of peep out this problem. What's happening all the time? What can we use to our advantage, okay? So let's go over here. Let's look at the equation. It is 2 times the quantity of 4x minus 3 equals 4 plus 2x plus 8. So that's the original equation. I'm going to use the equation letters to kind of guide this conversation. I'm going to write them down so you can see and know what's happening here, okay? So first thing I want to do in this situation is, let me get my tool. I want to go ahead and apply letter C if you're looking at that equation doc. And that's going to be distributive property. So let me do my smart cut so I don't confuse that. I don't know, maybe I want to subtract 3 from 4x, something like that. I know right there. All right. So then apply the strip properties, go there. 2 sets of 4, 8. Bring down the x. I have one negative sign that I can see here when I'm multiplying. Remember, if I'm multiplying and dividing, finding the product, finding the quotient, if I have an odd amount of negative signs that I see, the resulting product or quotient is always going to be negative. Now, if I have an even amount, it'll be positive. Okay, so notice I have an odd amount of negatives. That's why it's negative. 2 sets of 3, 6. So we're done on that side. So letter C. Could I have done B as well? I sure could have done B. Let's go ahead and do B down here. So I'm going to circle this term here and this term here. Now what I'm going to do is combine them. Why can I combine them and not combine this right here? Because these are like terms. What do I mean by they're like? They're numbers. I mean, I could make this, 1/4. I can still combine 1/4 with 4. Okay, so let's go over here. Algebraically, I have 4 positives. I had 8 positives. I have 12 positives. Okay, mathematically, 8 plus 4 gives us 12. And so what happens here is I do what? I combine like terms, letter B. So when I combine these like terms, I got 12, or 12 positives, however you want to see that. This equation I'm left with now is 8x minus 6 equals 12 plus 2x. So it looks like I made a decision for the variable to be on the left-hand side. So let me put my V for variable. Looks like I want the number or integer, constant, however you want to see that, on the right-hand side. So let's start playing the game. So let's get rid of all numbers on the right-hand side. Excuse me, let's get rid of all variables on the right-hand side. So I got 2 positives, I got 2 negatives. That leaves me with nothing. And I know you guys are saying, what do you mean by 2 positives and 2 negatives? I want to make sure you guys understand this on the number line. So 0. Let's say I have this positive 2 here. So 1 and 2. So 1 and then 2. But then I also have this negative 2 here. So 1 and 2 represent that movement. But then I have the negative 2. 1 and 2. It gets me right back to 0. So that's why. But arithmetic wise, remember 2 minus 2 is going to be nothing. Okay. So we do on one side, we're going to do on the other. So algebraically, 8 positives, 2 negatives, they're going to give me 6 positives. Mathematically, or arithmetic-wise, 8 minus 2, going to get 6. So you can see what I did here was I did an inverse operation. So if I did inverse operation, that's going to be a letter A. So let's move on down to the next step in the equation solving process. So I have 6x minus 6 equals 12. I'm getting close. I got my number over here. I have no variable, but guess what? I got a number on this side. So let's go ahead and just smash it out real fast. So if I have 6 positives, and remember I was using a number line here, or let's actually show you this one using negatives. So we'll go here, so 0. So I'm going to start at -6, obviously, because I'm trying to set you out. So -5. Uh-oh. Oh, boy. Let me make this thing go back down, y'all. All right. So then -5, -4, -3, -2, and -1. So let's say I went to, what was it, -6. So I'm at 0. -1, -2, -3. -4, -5, -6. But then I got, hey, 6 more positives. If it's positive, remember I'm going backwards. +3, +4, +5, +6 puts me at 0. Parents, you already know this because we got debit, checking accounts. So you see that negative, it's taking money out, all right? So if that makes sense, I really wanted to show you how I think using a number line when it comes to like negatives and positives. So once again, we have 6 negatives and 6 positives, leaves us with nothing. what I do on one side, I must do on the other. So 12 positives, 6 positives, 18 positives, or arithmetic, 12 plus 6, 18. So that was another inverse operation. So that was an A, but that would involve, notice, numbers, integers, constants, however you want to see it that way, as opposed to variables up here. So let's go down to our last part, and that's what part I always call FB, baby, because it's all about the fraction bar. We're just dividing here. So whatever the coefficient is what I divided by. So eyeball check, as I call it. I see 6 as the coefficient. I divide by what? You guessed it, 6. So let's do our wind up. Boom. And then I get my invisile uno, because we know that how many sets of 6 are in 6? 1. Well, what I do on one side, I do on the other. Do a wind up. How many sets of 6 are in 18? 3. Cool. So my solution is x equals 3. Let's verify it, okay? Okay, let's not just trust this, let's verify it. So we go over here, we take the value of x, and we plug it in everywhere that x was up here. So notice 4x, 4 times 3. We got another up 2x here, 2 times 3, because remember, they're hugged up. So this is multiplication, this operation. And as we go through the whole process, you find out that, hey, check it out. 18 equals 18. This means that the number or the integer or constant on the right-hand side is the same as the one on the left-hand side. This is important to know because this means that 3 truly is the what? The correct solution to the equation. That's the only number that can make that equation correct, okay, that you would plug in here, as you saw. If I put any other number, it's not going to be the same. It would tell you that. All right, so I hope that helped you, and we can go on to the next slide.